Hi viewers, this is Sri Ramlu. Today's topic is a Kroning-Penney model. Kroning and Penney explain about the behavior of electron when it is moving in a crystal. So crystal means generally lattice points arranged in this manner. Suppose electron is moving in this crystal, then how its energy changes, that is explained by the Kroning and Penney. Potential of electron varies periodically in a crystal. Varies periodically means sometime value potential energy increases and later decreases, increases, decreases. That is called periodically or periodicity. Potential of electron is zero near positive core. Positive core means nucleus, and it is high in the middle of two ion cores. So let's see here, when an electron is nearer to this positive core, so this is let it is a crystal. In the crystals atoms are arranged in this manner, or it is a positive cores or lattice points are arranged like this. Suppose one electron is coming from one side, and what happens, it starts attracting with this nucleus or positive core. Then what happens when it is coming towards it, attraction is more. Attraction more means potential energy decreases at this point. So right, so potential energy decreases at this point. See here, energy potential of electron is zero near positive core. When it is very near to the nucleus, its a potential value very smaller value, right? And it is high where it is high in the middle of two ion cores. So when this electron is moving just away from this positive core and reaching to the middle point of two ion core, then what happens, while it is moving away from it, its potential energy gradually increases, and when it is in the middle, its value is very much high, means maximum value. And after middle, if it is moving towards another positive charge, then its potential energy, what happens, decreases. When it is very nearer to the next ion core, its value is very much small, right? So like this, potential energy increases, decreases, increases, decreases, increases, decreases in this manner. So it is a periodicity. Why? Because same thing is repeating again and again, so that is we call periodicity or periodically. Now there are the two regions I divided. One is a higher region, other one is a lower region. So it is a higher value and lower value, high potential, low potential. Let potential of electron is low, means that is zero in the region 1, and high in the region 2. So it is a second region, it is a first, second, like this. And see its boundaries of first region is 0 to minus b, and second region is 0 to a. Applying Schrodinger equation. So what is a Schrodinger equation? Generally, so Schrodinger equation is del square psi plus 2m by h square e minus v in general. But what I have taken here, potential energy I have taken as v naught, then in the place of v naught is written into psi is equals to 0. Let it is the equation 1 for the region 1. So let me apply this equation for the region 1. So region 1 is lies between minus b and 0. Why it is x is taken? Moving particle is in one dimension, so that is why x direction is taken. So in x direction, its value, generally its formula is dou square by dou x square plus dou square by dou y square plus dou square by dou z square, in this manner. In one dimension means only we have to take this one and exclude the remaining two things. So this is, so in the region 1, potential energy is what? It is minimum, that is 0. So in the place of p naught, 0 is substituted, and then this formula becomes this one, that is we know appearing clearly. And now what I'm doing, I'm going to replacing, I'm going to take a substitution in the place of 2m by h square into e. In the place of e, let me substitute alpha square. So that means alpha square is what? 2m by h square into e. Next let me apply the Schrodinger wave equation, the first equation, to the region 2, second region. So second region lies in between 0 and a. So that region lies between 0 and a, that is along x direction, that is why x coordinate is taken. So dou square x by dou x square, only x square term is taken, into psi plus 2m by h square e minus v naught. So just now I said you the potential energy is very much high in the region 2. So that is why higher value cannot be negative. So it must be positive. So that is why let me take common minus outside. So it is minus outside. Then what happened? These two things reversal. Okay. Now let me take one more constant in the place of this as beta square. So here beta square is 2m by h square v naught minus e. Right. So here see, it is this is a equation 2 and it is equation 3. So these 2 and 3 are important equations for us. So these two equations are second order differential equation. See, dou square by dou x square. So it is a second order differential equation. For this solution we need for second order differential equation. So for the solution I am taking Bloch's theorem. So already I explained the Bloch's theorem, and video is also uploaded, Bloch's theorem video. So please watch that video. Now psi of x is equals to u of x e power I k x. It is not general formula. So general formula is psi of x is equals to u of x. So not x, these are not x. Psi of r is equals to u of r into e power I k dot r. So where r is a position vector, that is in terms of xi plus yj plus zk. But here only in one dimension means I have taken x components. That is the reason ikx is written. Above theorem is the solution for the equation 2 and 3. Just now I said you solution differential equation. It third differential equation, and a second differential equation is this one. So these two are the second order differential equation. That is why for them solution is fourth equation. So therefore differentiating equation 4 twice. Why we have to differentiate twice? Here dou square second order means twice. Differentiating equation 4 twice and substituting in the equation 2 and 3 and simplifying we get. So what I am doing here, I am neglecting middle matter. Why? Because that is a no need in the examination also. Why? Because it is a already lengthiest one. So again if you add the things, it is very much length. It is very difficult to understand and difficult to keep in mind. So that is why I am neglecting them. Okay. So by doing differentiating twice it and keeping this value after differentiating in the equation 3 and in the equation 2 also, and then if you simplify 2 and 3 after substituting the second order differential equation, this one, then what we get this is the equation, fifth equation we get, right? That fifth equation is you must keep in mind as p sin alpha a by alpha a plus cos alpha a is equals to cos ka, where p means what? P is the m v naught a b by h cut, that is p. Equation 5 is the solution for equation 2 and 3. So it is a solution. So for this solution we have to calculate energies in different cases, in two cases. So those two cases also given. Case 1, see what is the case 1. When p tends to infinity, That means when p reaches to the infinity, then what happens? So let me take the equation 5. This is the equation 5. Yes. So for this equation, divide with p on either side. After dividing, what we get here? P on either side. Now what happens? This p gets cancelled, but here p here and here p remains there. Now substitute p value infinity, where here and here. So why? Because here no p, already cancelled. Then something by infinity becomes 0, right? So that is why 0 is written. And next here 0 means sin alpha by alpha is 0, and then bring this alpha this side, that is also 0. Then finally we get sin alpha is equals to 0. So at what angle of sine we get zeros, right? Suppose if we substitute if we substitute here alpha a as 0, then sine 0 is 0, alpha a as pi, then sin pi is 0, 2 pi sin pi is 0, 3 pi 4 pi. So for all these values, what happens? Sin value becomes 0. Okay, from this alpha is equals to, bring a this side, yes, squaring on both sides, then we get this one, equation 2. See here, from equation 2, why equation 2 is needed? There we have the alpha square term. So once again, let me go back, second equation. See here, in the second equation, alpha square is 2m by h cut square into e, right? Alpha square term, that is, see here, 2m by h cut square into e. What that is? What that is? Alpha square term is equals to n square h square n square pi square by a square, right? Now see, and keep here e this side only, and bring these two quantities this side. So it is multiplying, it is dividing. So this become reverse. It upside value goes downside, and downside value goes upside. See here. So upside downside value upside value downside, means in denominator. That is the meaning of this. Okay. Now it is e value we got like this, but it is h cut square. H cut value is what? H by 2 pi. So h cut square means h square by 4 pi square. So this pi and pi gets cancelled. 2 to 4 to the 8, and upside is n square h square. Why? These two gets already cancelled. So this is the total energy of electron when it is attracted with the nucleus, means when it is moving inside the nucleus. Next, case 2. What we get? Case 2, when p value tends to 0, then, so from equation 5, so this is the equation 5. So substitute in the place of p as 0, it is 0. So into p 0 into something plus already these two terms. So this term totally is 0. Why? Because 0 into some value is 0. Then these two are equal here. Then both side cos are same. When their angles are equal, then only two causes are equal. So that is why their angles are I equated. A got cancelled already. A cancelled. Okay, and alpha is equals to what? K square on both sides. Then we get this one, and alpha value or square value we know that is 2m by h cut square to e, but k value is 2 pi by lambda. K is called propagation constant, right? That value is also substituted. E value 4 pi square h cut square. So why? So bring this h value, now it is dividing, and this side what happens? Multiplies. It is multiplying, this side it divides. And same thing in the place of h cut square, substitute this term h square by 4 pi. Already 4 pi gets cancelled. Okay, and now h square remains by 2m lambda square. So separate the h square by lambda square like this and write common. Okay, keep it like this. From the according to de Broglie is what? Lambda is equal to h by p. From this p is equal to h by lambda. Now see, H by lambda value is given. Can we substitute in the place of that as a P? Yes, P is substituted. Now Pe can be written as mv. Why? Because P is a momentum product of mass and velocity. So that is why in the place of P, mv is substituted, and write separate squares, m square v square. So for square, 1m gets cancelled, 1m remains here. Okay. Now then we can write that equation as like this. Okay, so this indicates when electron is not attracted, it is not attracted with the nucleus, then it has the kinetic energy value or total energy in the form of kinetic energy. That means it moves freely with the velocity, with the energy half mv square. So that means it indicates kinetic energy. Now see the final conclusion. This is the actually here this is the total energy of electron when it is free from attraction of nucleus. When it is attracted, that we get with that formula. When it is not attracted, then we get this formula. Okay friends, thank you friends. Don't forget watch this video till the end. Don't forget subscribing and like it. Thank you.